Hi students, here's an intro to ecological restoration. Here's some San Marcos students at UCSB planting native grasses in 2014. This is out by North Campus or SANS. So the short definition for ecological restoration is the process of repairing damage caused by humans to the diversity and dynamics of indigenous or native ecosystems. Diversity meaning the number of different plants and animals, and dynamics, how they're interacting with each other and with the abiotic factors like water, etc. There are other definitions too. The discipline of scientific inquiry dealing with the restoration of ecological ecosystems. In the simplest form, it would be just removing a perturbation and allowing natural recovery. So whatever might have damaged the ecosystem in the first place, get rid of that and then let nature take its course. Or full restoration, creating a once again resilient ecosystem with the capacity to recover from stress. And this is really what we're aiming for, is this idea that the system can get reestablished to be able to support itself, even when there are other stresses that might come along, like wildfires and things like that, that it would still have that ability to rebound. It might not be exactly the same mix of plants and animals, but it still has that same level of resilience. A little history here. The first, this really started in 1930s. 1935, Aldo Leopold and the CCC, Corps of Conservation Corps. I know there's one part I'm missing, one part of that C there. They replanted tall grass prairie, Curtis Prairie, on worn out Wisconsin farmland. And it had been overworked, this land, wasn't supporting crops, and it was ecologically restored using the native tall grass prairie. So this area is called the Curtis Prairie. Here's a picture of a crewman. So this is the first restoration project in the United States. This is a different crew watering it, 1930s. You can see here, no, I don't know, I guess you could say no trucks with big sprinklers, but a lot of manpower or human power. And one of the things that we now know to help keep that nutrient level and fertility of the soil lasting longer is to burn the prairie. By burning it, you're taking the nutrients, you're restoring them back into the soil. That's one part of it. But you're also getting rid of invasives that have come along. And ultimately, when you think about ecological systems, they're adapted to what is natural for that area. And it's natural for fire to come through prairies. Prairies don't get a lot of rain, so they're oftentimes very dry and prone naturally to wildfire. So the plants there, they have deep roots so that even though the tops of them are burning, they can regrow, resprout after the fire has passed through. And they do so in a way where a lot of the nutrients from the vegetation that was above ground has been returned to the soil as ash. And a lot of competing pests, maybe insects that may have moved in, or other other invasives that may have moved in, have been wiped clean. We'll take a look at some animal restoration projects. One of the most famous is the gray wolves in the United States. You don't have to know the details of this, but let's just take a look at some general timeframes. And it used to be that wolves were all over the North American continent. 1900, gray wolves had almost disappeared from the eastern US. And from the 1900s to 1930s, they were almost eliminated from the western US. So they were mostly eliminated because they weren't good for cattle raising. They would come in and they would kill the animals. So that was a loss to ranchers. But then as you can see here, big game hunting limits, a lot of populations do increase. So at some point here, because they're seeing more wolves, because they were seeing more food for the wolves, they were getting to a point where they're like, okay, we need to really get rid of these wolves that are now coming back in greater numbers. So they started poisoning them. In the end, it got to the point where we were wanting to reestablish the native wolf population because their populations had diminished too much from being killed by the thousands from the poisoning. So as you can see here, that's when in 1974, they were listed as an endangered species. And the Endangered Species Act of 1973 allowed that to happen. And then the recovery program began in the 1990s. So you could say the success of this is that they have become delisted as a endangered species. They no longer are. And but the whole process was not without controversy. And here we see a wolf that's being in the process of reintroduced. So a lot of these wolves were raised in captivity, but you can see here that were a lot of protests around this time. And keeping in mind that for many people, their livelihood was being diminished by the presence of the wolves because it was cutting into their profits as ranchers. There were reports that were made to the government. And in the end, from some of the results of that research, that most of the species of prey being killed by wolves was elk, 98%, as you can see here. So even though a lot of people were saying, why should we bring back this predator? It's a top predator. It can kill just about anything in its surroundings. And we want wildlife to be flourishing, not to be killed by these reintroduced wolves. Well, from that study, they can see that most of it was elk being killed, and that actually that had a lot of benefits. So there's a famous video, which if you took apes, you've probably seen this and you probably remember it. I'm going to ask you to pause this video and go and take a look at this How Wolves Change Rivers. You can click on this link from the slide deck that you have, or you can just also go to YouTube and type in How Wolves Change Rivers. Okay, so it's about a 4-minute video. So as I said, I'm going to skip over this for now because you'll be able to get better quality on your end. Sorry, that was my dog. Just kidding. Okay, well, let's see here. I'm going to go to the next slide. There we go. So in general, it's not very successful to try to reintroduce animals. Only about 16 of 145 reintroductions of captive bred individuals have been successful. And of the of reintroductions of native, threatened, endangered, or sensitive animals, only 46% have been successful. So one of the reasons that these rates are as low as they are is generally because animals are being reintroduced to areas that are themselves degraded. So the animals might reject this habitat, they might leave, they might go off searching for better food or better habitat. And in that way, they often perish. There's also worries about the overall health of the animals that are being reintroduced. Sometimes they're taken from a relatively small number of individuals, so genetically they might not be that diverse. So their immune systems might not be that strong, causing them to fall victim to sicknesses, illnesses, viruses, fungi, infections, things like that in their environment. So it's not an easy process. But we have had some major successes though, and the gray wolf is considered to be a success. Our speaker from UCS, our speaker from Channel Islands Restoration will share with us details about her experience with the Santa Cruz Island restoration. One of the main animals that we were seeking to restore is the island fox. So we'll hear more about that from her. There are different types of restorations. We've talked about animal restorations. We talked about prairie restorations. Riparian is restoring the vegetation along waterways, rivers, and vegetation is really important for the water for a number of reasons. Some of them being that the vegetation provides shade so that the water doesn't get too warm and put the aquatic animals outside of their zone of comfort, or what we also call their range of tolerance. Also, these plants, they're doing photosynthesis, so they're helping to add oxygen into the water if the plants are living in water, or at least partially living in water. And they're also providing shelter or protection for the aquatic species from bigger prey. So there's little places to hide out amongst the vegetation. And also the roots of the plants can help to stabilize the banks of the river. So there's a number of reasons why, in order to have a healthy riparian aquatic biome, you need to have healthy vegetation. We'll take a look at another example here. Garbage dumps. This is called Fresh Kills garbage dump at Staten Island, New York. It's a pretty famous one. And it nowadays doesn't look like this. It looks like this. So this trash is still all there. It's just being covered up. It is covered up by dirt, and the dirt has been replanted. So there's some trees, some grasses, things like this. But is this actually truly like restored? I mean, it did not used to look like this, right? The lay of the land is going to be different because now it's a hill, and the conditions are different. Like, you know, it's not fresh air. This trash is still emitting gases. They're still seeping up through the soil, entering the atmosphere. So there's a limit to what you can use this type of land for. It's okay if you keep the land open, like people to come and play on, it's okay. But if you were to like pop a building on top of it, like a school or houses or shops, then that building can be a trap for some of these gases that are coming out of the landfill. And then those gases can build up in concentration inside. You can be getting sick and bad problems. So, so there's a limit to what you can do with this land. You can only use it for things like parks or wildlife spaces. But at least it's more sightly, meaning it looks better. At least it's not going to be attracting wild animals coming to eat the trash. And it's not going to be spreading debris when there's storms and things like that. And it can be a place to play. Here's an example of mine reclamation, where we're doing strip mining, clearing off, where we have cleared off the vegetation, scraped off the top layer of soil to get down to what we want, which in this case is coal. In the end, this can be reclaimed as well, bringing in soil to cover up the exposed rock and then replanting it. Not an easy thing to do. Just the sheer massive volume of stuff that's moved. Everything was totally disturbed. You know, there wasn't any vegetation left. So now you're trying to restore starting from ground zero. And that, you know, even soil itself takes hundreds of years to develop naturally. So just bringing in some soil like this, it's going to take a while for the soil to become living, for the organisms, for the plants to be able to develop those relationships with the soil and with each other through the soil. So it's a long process, but it can reduce problems associated with having bare rock exposed in mines, things like minerals leaching from the rock and causing the water to become acidic. We call that acid mine drainage. So that's a big problem that this helps to mitigate or make less worse. So I use the word mitigate in sort of the wrong way, perhaps, or in a different way just now. Mitigation is also a legal term, which is the alleviation of some process, and that's a general term. In this case, mitigation is related to restoration, is that you can allow a group to destroy a wetland and a place where they might like to build a nice housing development if they agree to restore a degraded wetland somewhere else. So it's like, okay, you're building this project, it's going to be bad for the wetlands, but we're going to mitigate the problem with that by having you do some good over here. And hopefully the two balance out. This would be ideal. So it's controversial because the success rates for these mitigation projects is usually fairly low. What that means is it is hard to restore an ecosystem. For us to think that, oh, we can just redo it is sort of, you might say, kind of arrogant thinking, because nature has created these ecosystems over countless hundreds of thousands of years. At the very least, over countless thousands of years. So it's hard to just go in and recreate that. And people fear that if we see this as a viable way of allowing development, then we're going to see too much development on lands that are currently undisturbed. So it can be a little bit wishful thinking. When we talk about doing restoration, shifting gears a little bit here, the question is always, well, how much, to what extent, what's the goal here? And the general word reclamation is the process of repairing damaged ecosystems. Well, Yes, but restoration is like, how much are you trying to put back exactly the way it was? Is it possible to do that? So to be fully restored would be it back the way it was. And we try to, and I kind of think of this a little bit like people have like knee surgery, for example, like you're getting new knees because they're old and their knees are shot. You could try to restore the knee by putting back the cartilage that was there and things like that, but it's really hard to do. You know, like your body only has so much cartilage, you can't regrow cartilage generally. So it's hard to restore, but you can rehabilitate. You can do like, you know, treatment or rehab therapy, which is trying to do like exercises with your knees to try to make the cartilage that is there stronger. And cartilage can slowly heal in some cases. By the movement of the joint allows nutrients to come in and waste products to move out. And not so much through the blood, but through the clear fluid in there, the synovial fluid. So this can help. So rehabilitation is you're putting back kind of most of what's there. You're kind of like doing what you can, but you know you're not going to get it back exactly. Replacement would be, let's like get rid of the knee and let's put in an artificial knee or a new knee. Okay. Recovery or neglect is where we're basically saying, just let your body kind of just keep doing it. Try whatever you were doing that was making your knee bad or painful, stop doing that and just give your body a chance to try to just heal naturally. That would be more like recovery or neglect. And then enhancement would be things like maybe giving yourself a new knee that's like souped up, like the RoboCop version. So you can Bionic Man kind of deal here. So you're getting the new fancy like greatest new alloy of titanium or something. But that's there's a lot of words for a picture here. And this picture is showing that if you got an ecosystem, you can see ecosystem structure down here on the bottom and ecosystem function. What we ideally wanted for the ecosystem to have good structure and good function. So it's got the plants there that it needs, and the plants are functioning well with each other and with the animals. So a degraded ecosystem is going to be low on both of those. If we just neglect it, it can kind of go either way. It might get worse, it might get a little better, but probably not going to be getting that much better. If we rehabilitate it a little bit by bringing some plants in that can help a little bit, those plants can then start to reproduce and spread, then we're on the process of rehabilitation towards restoration. We might decide that this is just not going to be possible to rehabilitate. We should just replace this ecosystem with some different types of plants, not try to restore what was there before. That would be replacement. And once we get to a point of restoration, we can try to make it even better by enhancement, doing little things that might allow even more diversity to exist there. You know, this is where it's like, you're already kind of going in and doing things that are sort of like manual or that weren't just natural, because natural just be neglect. But maybe you can reroute or bring in some more water, for example. Maybe you can sort of clear away some vegetation in some area to kind of maybe try to recreate some kind of like meadow that perhaps used to be there. Maybe regrade the land a little bit if you are trying to reestablish what used to be a meadow and kind of became more of a forest. So enhancement is more like, can we add more diversity to this area somehow? There are 7 basic steps here, and you have to have a goal. So deciding, are we going to be trying to restore it? We're just going to try to rehabilitate it and let it go from there. Are we going to try to enhance this and make this just a really killer functioning system? So determine your strategies and your methods. Always have to have a plan. One of the biggest things I want to focus on is number 3, removing the source of the degradation. No point trying to restore it if whatever was damaging it is still there. So in the case of the Channel Islands, we'll learn about the boar, and these wild boar would go and tear up the roots of the plants and just cause massive destruction and erosion. So get rid of those guys first. And then you can go about restoring the physical environment. And by that, we're talking about trying to regrade things, which means like reslope things as needed, or trying to reestablish certain flow of water, for example, and then restoring the plants. The physical environment and the plants are very closely related, because things like the biota, which is the plants, they're going to help to be stabilizing soil, which is going to help the soil to become restored. So it's not like necessarily one happens first and then the other. But you have to, but there might be some steps of the physical environment that have to be repaired first. And then be patient. We're talking about plants here, so they can take decades to get established. But wanting to monitor it and maintain it as needed through that, because even though it might take a long time, you want to make sure things are going in the right direction. Otherwise, you should intervene to set things going in the right direction. I love this quote. It's by Frank Igler. He's a restorationist. He says, ecosystems are not only more complex than we think, ecosystems are more complex than we can think. So the reason I like this is because in science and technology, we have this sort of underlying idea or premise that we're able to dissect things about our world and reduce it down to its basic components and understand how they work together. But ecosystems have so much relationships happening between there, so much dynamics, that it's almost impossible to be able to actually study, let alone recreate, the complexity of all these innumerable interactions between innumerable species. So we're best to keep what's already functioning. So some other examples here, Santa Barbara has a lot of examples of restoration work. And the Arroyo Burro, also known as, otherwise known as Henry's Beach, is one example. Douglas Family Preserve, some of these you may have heard of. UCSB has some restoration work. We saw that on slide 1. The Arroyo Burro Estuary. This is an area over by Henry's Beach that, no, I'm sorry. I misspoke here, but let's talk about the area by Henry's Beach for a moment. Arroyo Hondo, that is. Arroyo Burro is a little bit further up the coast. But Arroyo Hondo is an area where they also did restoration recently. And one of the goals of that was to eliminate the amount of bacteria from dog feces up at the top of there, which is called the Wilcox property, where a lot of people walk their dogs. And just by having more vegetation in that area, you're able to slow down the flow of water and get the water to infiltrate into the soil. And from there, microorganisms can break down the organic matter or break down the pathogenic, meaning bad bacteria that might be in the feces, to keep it from flowing all the way into the slough right there at Henry's Beach. So in general, when we have more vegetation, we get more slowing down of the flow of water, which gives us more infiltration into the soil. And from there, anything that might be pathogenic in the soil or in the water can be broken down. So there's a whole program at City College on ecological restoration. It's a 2-year program. And from that, people have the background to take on multiple careers in restoration. A lot of these careers are with the federal government. As you can see here, different organizations, Fish and Wildlife Services, Forest Service, etc. Or for the state, California Fish and Game Department. Or in the private sector, environmental consulting, native plant propagation facilities. So places that might contract with government agencies or with NGOs, non-government organizations. As far as laws go, we've already talked about Endangered Species Act, and that's a really important one because that allowed money to be spent for restoring habitat, because you can't have species that are endangered survive if their habitat's degraded. Okay, and so with that, hopefully we have some good background for learning more about the Channel Islands area and how it has been restored successfully. And I want to thank you guys very much for your attention this morning. Be well.